Hello class, we're about to start section 7.4, properties of exponents. Recall in section 7.2 and 7.3 we saw the following two properties. The product property for exponents. We have x to the m times x to the n. They have the same base, so you carry over the base and you add the exponents. So when you multiply with the same base, you carry over the base and add the exponents. Now, when you raise a product to a power, this is what happens. We have x times y in parentheses, but n is on the outside. We have to remember that the exponent of x is 1 and the exponent of y is 1. So, this is saying that this n that is taken to, well, x and y is taken to the power of n. So what you would do here, you have x to the 1 times n times y to the 1 times n. So that means you multiply those exponents. So it'll end up being x to the n, y to the n. Now we have a couple examples here, well actually a few. So we have in parentheses 5a to the 4th times b squared times 3a to the 5th times b to the 4th. So we would take 5 times 3, which is 15. A to the 4th times a to the 5th. They have the same base, so you carry the base and you add the exponents. Now we go here to b. We have b squared and b to the 4th. You put the base and then you add the exponents. So now your final answer would be 15, a to the 9th, b to the 6th. And this will be your final answer. Now, of course, as you go through and do these problems, you don't have to show this step of how you added to get these numbers here. You can actually add in your head. Okay, now we go to B. We have negative 3 TW in parentheses, and it's all taken to the 4th power. Now remember, all of these are technically taken to the 1st power, the 3, the T, and the W. So we will have now, this negative is also taken to the 4th power because it's inside of the parentheses. We know a negative taken to any even exponent will make that positive, correct? Okay, so we know our final answer is going to be positive, so we don't need the negative anymore. So it'll be 3 to the 1 times 4 times T to the 1 times 4 times W to the 1 times 4. Because we multiply these exponents. So this will give us 3 to the 4 times t to the 4 times w to the 4. Now, 3 to the 4th power will give us 81. Then we will add t to the 4, w to the 4, and we're done. Now we go here to C. We have 3x to the 3rd times a negative 4x to the 6th. So we would do 3 times negative 4, which would give us negative 12. X to the 3rd times x to the 6th. We have the base, we carry over the base, and add the exponents. So it would be negative 12 x to the 9th would be our final answer. Are there any questions over example 1A, B, or C? Any questions? Okay, now, we go down here to a power expression. It's an expression that contains one or more powers. Now, it includes no parentheses. And any monomial term, each variable appears as a base at most once. For example, we write x to the 3rd times x to the 5th as x to the 8th. Each numerical expression, such as 5 squared, has been calculated and each numerical fraction has been simplified. So these are basically the steps for simplifying a power expression. Now we can simplify x to the 5th over x to the 3rd by writing it out. Now we write out our 5x's here and our 3x's here. Now if you notice, since this is division, we know we can simplify out the x's that match up here. We had 3x's from the numerator and 3x's from the denominator that will simplify out. And that would leave in our numerator x squared, and our denominator would leave us 1. Because when everything simplifies down here, that's 1. And x squared divided by 1 would just leave us x squared. Now we're asked here. It says the quotient property for exponents. If m and n are whole numbers and x is non-zero, then x over m divided by x to the n will give us x to the m minus n, which we could have done up here. We have the same base, and I'm just going to write this off to the side. We'll carry the base and then subtract the exponents, and it still will give us x squared. That's basically what we did here without expanding it. Are there any questions? Okay, so we scroll on to the next page, and we're asked here to simplify. Now we have 6x to the 7th over 9x to the 4th. So first of all, let's deal with these numbers first. 6 and 9. What does 6 and 9 have in common? 3. So we can divide both of these by 3, and we will have a 2 in the numerator and a 3 in the denominator. Now we deal with these variables. We have x to the 7th over x to the 4th. This means we can go off to the side. We will write our base, which would be x, and then we will subtract the exponents. 7 minus 4 is 3, so this would be x to the 3rd power. And since it's x to the positive 3 power, that goes in your numerator. So it'd be 2x to the 3rd over 3, and that would be your final answer. Now we come here. We have 4x to the 9th, y to the 5th, over 6x to the 7th, y squared. So we'll start it off like we did A. We'll divide the numbers here. They both have 2 in common, so that will give us 2/3. And then we look here at the variables. Now, there's another way we could do this. Instead of going off to the side, if you notice, when you have the same variable in the numerator and denominator, if the exponent is larger in the numerator than the denominator, when you subtract, that variable would be in your numerator. So positive 9 is greater than 7, right? And we know 9 minus 7 would give us 2. So this would be x squared in our numerator. Now we go here to the y's. Y to the 5th, y squared. We know 5 is larger than 2, so it'll be y. 5 minus 2 is 3. So it'll be y to the 3rd. And this is our final answer. Now we come here to C. Start off the same way. 20 and 15, they both have 5 in common. So this will give us 4 for the numerator, 3 for the denominator. Now we look here at our A's. Now, 8 is bigger than 6, so we will subtract 8 minus 6 is 2, and that A squared will go in our numerator. Now, we look here, we have our B's, B to the 5th over B. Remember, this B is assumed to be taken to the 1st power. So 5 is bigger than 1, 5 minus 1 is 4, so it'll be B to the 4th power in your numerator. So your final answer would be 4a squared, b to the 4th, all over 3. Are there any questions on any of these problems? Okay, now, we go here to this next example. It says we can simplify x, y in parentheses to the 3rd by writing it out. So what we would have is 3x's in the numerator, 3y's in the denominator. And then our final answer would just be x to the 3rd over y to the 3rd. Now it says here, if n is a whole number and y is non-zero, then x over y to the n equals this here. Now listen, remember this x is assumed to be taken to the 1st power, and this y is assumed to be taken to the 1st power. So whenever we take a power to a power, we multiply. So we'll have x to the 1 times n, which will give us x to the n, and y to the 1 times n will give us y to the n. because this exponent, each one of these are taken to the n power. Now we come here to example 4. It says here in example 4 to simplify. Now we know that both of these are taken to the first power. So we know this would be x to the 5th over y to the 5th. Because this would be 1 times 5 and 1 times 5. Now we come here to b. Same difference. This is x to the 1st. This is 4 to the 1st. So this will give us x to the 3rd, because a power to a power we multiply. And 4 to the 1st to the 3rd will give us 4 to the 3rd power. So this will give us x to the 3rd over 64. Now it says here, we can simplify x squared to the 4th by writing it out. We have x squared times x squared times x squared, which we know would be x to the 8th. It says if m and n are whole numbers, then x to the m to the n will give us x to the m times n, which is basically what we've been doing. And just to write this out, just to show it, this would be x to the 2 times 4, which would be x to the 8th, which is the same thing that we have here. So now we go on to example 5. Example 5 says simplify. Now they give us x to the 3rd to the 5th. So now, we know this is a power to a power, so that would give us, okay, there were technical difficulties. But we will take x to the 3rd to the 5th. We will multiply the exponents. 3 times 5 will give us x to the 15th. Now we go here to b. We have b to the 4th to the 7th. We know that would be the same as b to the 4 times 7, which is b to the 28th. And that will be our final answer. Now we come down here to this table. It says the summary of the rules of exponents. Now we want to simplify, put the rule in words, and then do the rule in the symbols. So if we simplify this, we know this will be a to the 8th power. Then we have x to the 5th over x to the 2nd. We know that would be x to the 5 minus 2, which would give us 3. So it would be x to the 3rd. Here, x times y to the 4th. We know this is x to the 1st, y to the 1st. And you know, like we had before in the previous exercise, sometimes this jumps when it's in the chart. So we know this is x to the 1st, y to the 1st, to the 4th. So it'll be x to the 4th, y to the 4th. Now this is r to the 1st over s to the 1st to the 3rd. So we know we will have r to the 3rd over s to the 3rd. Now we have y to the 4th to the 3rd. We know this is a power to a power, so we multiply, so it'd be y to the 12th. Now the rule in words, I'm just going to verbally state this. So this rule in words goes like this. Whenever you have the same base and you're multiplying, you add the exponents. You keep the base the same and add the exponents. So I say it again. Whenever you multiply with the same base, you keep the base and add the exponents. Next, here with the division. When you divide with the same base, you keep the base and subtract the exponents. Yes? Oh, thank you. I made an error. This is supposed to be a to the 6th, not a to the 8th. The only time we multiply the exponents is when we have a power to a power. So that was my error. Thank you, young lady. Okay, so again, according to the rule, multiply, you keep the same base, you add the exponents. And then here when you divide, you keep the same base and you subtract the exponents. Here we have the multiplication and it's taken to a power. You will take each individual factor and its power and multiply it to the exponent. So this is how we get x to the 4, y to the